Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 323, number of connected components in an undirected graph. Now this is a medium level graph problem, and you're probably wondering why I'm on Leetcode.io and not Leetcode, the Leetcode site itself, and that's because Leetcode requires you to have a premium subscription, which I don't, so I'm going to be solving this problem on Leetcode instead. So I told that we're given an undirected graph with n nodes. There is also an edges array where edges I equals AB, means that there's an edge between node A and node B in the graph, and the nodes are numbered from 0 to n minus 1, and we have to return the total number of connected components in that graph. Okay, so we're told that we're given edges to be I equals AB, but that's not the case here. So in this example, node 0 looks like it's pointing to itself, so it's not exactly how it says in the question. We need to build our own adjacency list. But the way we're going to solve this problem is by doing depth first search in our graph, and depth first search will allow us to be able to isolate components in a graph. So in this example, we have 1, 2, and actually let's go back. Let's say 0, 1, and 2. So 0 is connected to 1, 1 is connected to, and 1 is connected to 0. So you can see that this graph only has one component. And if we go down to the second example, we return the output to this problem is 2. And the reason is because we have two components. So we have 0, which is connected to 1, 1 is connected to 2, 2 is connected to 3, and then we have 4, which is connected to 5. So you can see we've got two components. So we've got this component over here, and we've got this component over here. So we've got two components that we have to return. We don't have to return the components themselves, we just have to return the output. So how can we solve this problem? Well, the first thing, of course, we need to do is build an adjacency list. But before that, we do that, I just want to create our depth first search function. So I'm going to actually just create that just so that we have we don't have to waste time afterwards, just so that it's out of the way. So let's create that function, public static void, because private static void, because we are not going to be returning anything. We're just going to be marking nodes as visited or not visited. We're going to take an integer, a node. We're going to take in a list of lists of integers. So this is going to basically be our adjacency list. So adjacency list. And we're also going to be taking a Boolean array called visited. So this is going to be all the parameters, and writing the depth first search code itself. What we're going to say is, let's set this node equal to visited. So visited node is going to be equal to true. And for each neighbor, which each neighbor is going to be an integer, we're going to get from our adjacency list, not our graph, our adjacency list dot get node. So we're going to get all the neighbors from our adjacency list for this node, and we're going to say if that neighbor is not already visited, neighbor, we're going to do depth first search on it. So we're going to pass in our neighbor, we're going to pass in again our adjacency list, and we're going to pass in our visited matrix. Okay, so that's our depth first search function done and dusted. Now it's time to actually build our adjacency list. So build adjacency list, and to build our adjacency list, we're going to say for I equals 0, I is less than n, I plus plus, and n is the number of nodes in our graph. And we're going to add to, actually first we need to create our adjacency list, don't we? So we want to say list, I'll copy this declaration over here, so we get the correct types, and we're going to say adjacency list is going to be equal to new array list, which is going to be an empty array. And then for each node, we also want to have a set within a list within that list. So we're going to say adjacency list dot add new array list, like so. Boom. Okay, so now we've got our adjacency list fully created, or not fully created yet, because we need to populate the adjacency list. So we've just got the bare bones template at the moment. So we want to say for int for each edge in edges. So for each edge in edges, u is going to be equal to edge 0 and v is going to be equal to edge 1, and we're going to push adjacency list dot get u dot add v, and then do the same for v with u, v, and u. Okay, so the next thing we want to do now that we've actually completed building our adjacency list is check for components, or count components. So let's just change this to count components. So we want to create our Boolean matrix. So we're going to say Boolean, this is an array list. So we're going to say visited. It's going to be just a new Boolean array of n and of length n. And also we want our count. It's going to be the number of components that we return. And then we're going to say, let's just copy this over here. We want to say for each node in our adjacency list, if we have not come across it, then we want to add, we want to do depth first search on it. And if we have not come across it after doing depth first search, so let's say we do depth first search on these 3 nodes, and every time, once we finish depth first search on the first node, we're going to see that the adjacency lists, we can just skip these 2 nodes, because all these edges, because all these nodes, because they're already going to be in our adjacency list, and we know they're going to be part of the same component. When we get to these 2 nodes, we know that they aren't going to be in our adjacency. They're not going to be in our visited matrix again. Sorry. So we know that this is the second component. So every time we can also increment our components count. But before we do that, we want to first say, if not visited I, let's actually do depth first search. We'll pass in I, which is going to be the node that we're at, the adjacency list, as well as our visited matrix. And then we can increment our count by 1. So that's our adjacency matrix done, and that looks good to me. And then we can just return our count. So let's run our code. New Boolean, syntax error. Okay. Okay. That's a mistake on my part. Cannot find symbol I. For int I. For int I equals 0 here as well. Okay, let's run our code again. Oh, and our code is accepted. Fantastic. And we have successfully completed this problem. So we passed all 20 test cases. That is our solution done. In terms of time complexity, guys, it's going to be the same for time and space. It's going to be O of v plus e, where v is the number of vertices and e is the number of edges. And with that being said, I hope you guys enjoyed this video, and I'll catch you very soon.